Intro to Blockchain. I wrote a best-selling book called Blockchain: Blueprint for a New Economy to inspire us to build this world. A blockchain, or distributed ledger, is a software protocol. Just as SMTP is a protocol for sending email, blockchain is a protocol for sending money on the internet. In more technical detail, blockchain is the tamper-resistant distributed ledger software underlying cryptocurrencies such as Bitcoin for recording and transferring data and assets such as financial transactions and real estate titles via the internet without needing a third-party intermediary. How does it work? You use your e-wallet app to send money. If I want to send money to my friend, I open up my e-wallet app, such as Breadwallet, Mycelium, or Coinbase. I scan the recipient's address, I enter the amount, and submit the transaction. In a few moments, the money will appear in the recipient's wallet, in their wallet app. One point is that my wallet doesn't have money, it has keys. It has a public-private key pair addressing system such that every transaction is uniquely encoded. When I want to send money, my private key checks that I have the ability to transfer this money, checking out on the internet ledger balance, and signs a unique signature allowing the transfer of this money. Then when the network receives this transaction, the software knows how to confirm that indeed this is a valid transaction. What happens in the back end is that the transactions are submitted to the cloud mempool, a memory pool of transactions, at a certain location in the cloud. And every 10 minutes, mining software comes by and grabs a chunk of the latest block of transactions. And then these mining ASICs compete to see which one is going to be the one to actually record these transactions. The way that mining machines compete is that the same software network, the Bitcoin software, issues a random number every 10 minutes. This is called a nonce. It's a 32-character number about which some of the cryptographic parameters are known. And then the mining machines, all of the many, probably hundreds and thousands and millions and possibly billions of ASICs, making guesses at the rate of 4 billion per second as to this random number. At random, one machine will guess closest to the nonce, the random number, and win the ability to record the transaction and get the rewards. Then that miner updates the chain with the new block, which has a hash or a little signature of the previous block, which thereby chains all previous blocks together in an immutable linked transaction database, and updates the chain with a new block. The ledger balances then reflect the new transaction balances, and the block is sent out to all of the distributed nodes worldwide that maintain the software transaction ledger. This is a peer-to-peer network, currently consisting of approximately 11,000 nodes in the case of the Bitcoin network. Any person is free to host the Bitcoin blockchain node, the transaction ledger. You just download it from GitHub, and this is voluntary peer network contributed infrastructure. Bitcoin mining, more specifically, as I mentioned, is the accounting function to record the transactions. It's fee-based. It works in the way that mining ASICs find new blocks, discover new blocks with a proof-of-work software mechanism. As I mentioned, what happens is that the network regularly issues random 32-bit nonces per specified cryptographic parameters, and the mining software and hardware constantly makes nonce guesses at a rate of 4 billion per second. One machine at random guesses the correct random number and wins the ability to confirm and record the transactions and update the other nodes. The wasteful effort makes the system very secure. However, it is wondered and thought that we'll probably evolve to other kinds of similarly random entropy-based type systems with many network machines randomly guessing to record transactions, but that aren't quite so wasteful in their consumption of electricity. That would be the future method. So distributed networks is the idea that we've had three different kinds of network architectures: those that are centralized and hierarchical, those that are decentralized based on hubs and spokes, and those that are distributed, like the Bitcoin blockchain, just truly flat pure nodes, no one node having any different status than any other. The radical notion of pure nodes is that each node can be a peer who provides services to others. And indeed, that's exactly what happens currently. The transaction ledger is hosted by peer nodes. Transaction confirmation and logging happens by mining peer nodes. And now we're starting to see service applications on the network beyond network operations, including news, and then with payment channels, possibly banking. There are two kinds of distributed ledgers, public and private. Public being like Bitcoin and Ethereum, which are truly open public chains. Identity is not known, and many users are preferring even higher grades of privacy, such as Zcash and Monero. And there's been an announcement recently that Ethereum will be including zero-knowledge proofs to make its chain even more private. The other kind of chains are enterprise chains, or also called private. Private in the sense that they're like a corporate VPN, that only permissioned, credentialed users can perform certain operations. So the R3 Corda chain or the IBM Hyperledger Fabric, these are all enterprise chains that would be where users would be known and credentialed. There are four classes of blockchain applications. Number one, money and financial instruments. Number two, property, auto and house titles, for example. Number three, contractual relations, such as partnership agreements and wills. And number four, identity management operations, such as visas and passports. Thank you.